Hello, and thank you for inviting me to be part of the Australian Accessibility Conference. Today, I would like to talk to you about voice interfaces, which is to say that the front end has changed. It's no longer something that we need to think about in terms of just visual design, of color schemes, of content layout and presentation. The front end is now conversational, which means we need to think about the words that we use, but also the voices that we choose and the ways that we express those words. Hence the title of this talk. Are you talking to me? A simple question, but one that can be phrased and expressed in many different ways. If I were Hercule Poirot, I might, for example, say, "You are talking to me, mon ami?" If I was Yoda, I might say, "Talking to me, you are." And then, of course, there is all the rasping, drawling menace of De Niro himself. "You talking to me?" So not only are the words that we choose important, but so are the voices and the ways we use to express those words. And this, it turns out, is something that we've been working on for quite a long time. We can go back to 1961 and some work done by IBM on one of the first examples of humans being able not only to talk to technology, but to get technology to do something vaguely sensible in return.
Last year, an experimental machine that recognizes the human voice was introduced to the press by its inventor, William C. Dersch, of the Advanced Systems Development Division.
Our efforts to communicate with, that is, control machines, have resulted in a demonstration voice recognition machine capable of operating an adding machine. Shoebox 2, the name given to it because of its small size, recognizes the 10 spoken digits and in addition 6 command words: 6, 7, 8, plus, 2, 3, 4, 5, 7, 8, minus, subtotal. The machine has understood my voice and caused the adding machine to correctly perform these arithmetical operations.
A machine that recognizes the human voice. Evidence of IBM's continued exploration into the technologies of tomorrow.
And for pretty much the 60 years since then, we've been doing our level best to talk to technology and to get technology to understand what we are trying to say to it. Arguably, the modern era of conversational interfaces was helped by Voice XML or VXML, a standard from the W3C that has its origins in the late 90s and became a W3C standard for the first time in 2000. VXML, as the name suggests, is an XML-based markup language, so it looks very similar to XML and the HTML that we're familiar with, but rather than marking up chunks of content for display in a web browser, VXML marks up chunks of a conversation for use in a voice browser. And this is a very different piece of technology, though it effectively does the same job as the browsers we're much more familiar with, where our web browsers pass HTML, CSS, and JavaScript and present a visual interface. VXML voice browsers do the same. They just render voice content into a conversational interface. So same idea, but just different interface paradigms. And if we look at some basic VXML markup, we can see what will become a very familiar building block of a conversational interface. The prompt, this is the bit that the conversational interface says when the conversation is opened. It's the first bit of speech we hear from the conversational platform. The prompt element has one of the worst attributes ever, but the most splendidly named barge-in attribute. If you have ever had the misfortune to be stuck in the loop of a telephone menuing system that you've been through 26 times already, you know which options you need to choose, but it won't let you interrupt it and get on with the thing more quickly. It's the barge-in attribute that is to blame when set to false. It makes you listen to everything the conversational interface has got to say before it lets you get a word in edgeways. That aside, VXML also has a menuing property, menuing element, and this is another of the basic conversational chunks that we get very familiar with. This time it offers us a choice, in this case, continuing our imaginary telephone menuing system, a number of choices that will let us progress the conversation in different directions so that we might end up with something that sounds a bit like this.
Hello. And welcome to hell. Please press 1 to make the wrong choice. Press 2 to listen to elevator music. Press 3 if you've lost the will. Or press 0 to hear these options again.
Well, let's not and say we did. Fortunately, we can move on from voice XML and particularly telephone menuing systems. If we look at the basic architecture of a conversation, essentially something is said, something is heard, listened to, or absorbed. It's then processed or understood, and ultimately a response is given. This is essentially the way that people talk with each other, and it's also the architecture that we've translated into digital conversational interfaces. We use automatic speech recognition to take that first step of listening. Uh, Automatic speech recognition will be familiar to many of you, I'm sure, as part of speech recognition software or voice recognition software that are used by people with disabilities, particularly or often physical disabilities. But it's a technology that listens to what someone is saying and converts it into text. For anyone who's been working or interested in accessibility for more than just a few minutes, you'll know that text is one of the most versatile forms of information that we have at our disposal. And this is true of conversational interfaces too. Text is a fundamental part of being able to create a conversational interface. Apple has been doing this in its technologies since the early 90s.
Macintosh, open letter. Macintosh, print letter. Macintosh, fax letter.
While everyone else is still trying to build a computer you can understand,
Macintosh, shut down.
we've built a Macintosh that can understand you.
Goodbye.
Oh, if only it were that easy. But one way or another, we have been having the ability to talk with our technology, or at least in theory for it to listen to us and interpret some commands for a little while now. If we go back to architecture, the next part is linguistic programming. This is the bit that takes the text that was identified by the speech recognition and it converts it into structured data. Structured data is really important because it's the bit that effectively enables the next part of the process, the bit where machine learning takes that structured data and processes it in some way. This is, if you like, the thinking, the understanding part of the conversational architecture. It's the bit that goes on under the hood that's not actually part of the conversational itself or the conversational interface itself, but it's the bit that goes in and hooks up the input and output aspects of the conversation. And then the process starts to reverse itself. We take this time language generation, and this takes the structured data that is output by the machine learning and it converts it into text. And the last piece of the architecture is glued together with text to speech that takes the text and turns it into synthetic speech and effectively gives us the response at the other end of the conversational interaction. Again, we've been trying to get technology to speak to us for much longer than you might think. Here's an example of an entirely mechanical system from the 1931 World's Fair.
The machine uses only two sounds produced electrically. One of these represents the breath. The other, the vibration of the vocal cords. There are no phonograph records or anything of that sort. Only electrical circuits such as are used in telephone practice. Let's see how you put expression into a sentence. Say, she saw me, with no expression. She saw me. Now say it in answer to these questions. Who saw you? She saw me. Whom did she see? She saw me. Did she see you or hear you? She saw me.
Now that really is quite extraordinary for, as I said, a mechanical system and the way it is able to really emphasize different words and change the kind of cadence and reflexive responsive of some of those sentences. By the time we get back to 1961 again, what was it with the 60s? The people at Bell Labs had begun looking at digital synthetic speech. And of course, they did what every normal person would do. They made it sing.
Daisy, Daisy, give me your answer too. I'm half crazy, all for the love of you.
And of course, it gave us the origins of possibly one of the most famous science fiction movie scenes ever in the form of the speaking AI in 2001, A Space Odyssey. By the time we got to 2014, another evolution in conversational interfaces had happened. And this really was one of the first examples of a technology that enabled us to have what came very close to being a fully fledged conversation with technology. I'm talking, of course, about the Amazon Echo and Alexa.
Introducing Amazon Echo.
Hi there.
And some of Echo's first customers. Echo is a device designed around your voice. Simply say Alexa and ask a question or give a command.
Alexa, how many tablespoons are in 3/4 cup?
3/4 cups is 12 tablespoons.
Echo is connected to Alexa, a cloud-based voice service, so it can help out with all sorts of useful information right when you need it.
To me, it's, bringing technology from Iron Man at Tony Stark's house into your own.
Echo can hear you from anywhere in the room, so it's always ready to help.
I can have the water running, I could be cooking, the TV can be on in the back room, and she still can hear me.
It can create shopping lists.
Alexa, add waffles to my shopping list.
Provide news.
From NPR News in Washington.
Control lights.
Alexa, turn on the lights.
We use it to set timers. We use that feature all the time, and that's one that's specifically helpful, I think, uniquely to blind people.
Calendars.
Today at 1 p.m. there's lunch with Madeline.
And much more.
So let's take a closer look at how some of this works. Conversational interfaces are still incredibly limited. They're nowhere near as powerful, as capable, as flexible as human conversation, but they are still remarkably powerful things. And the Echo really is one of the most interesting platforms to enable us to build these conversational interfaces. A conversational interface has two essential components in the Echo ecosystem. It's known as the interface, speech interface, and the speech services. The interface being the equivalent of the front end, the bit that we actually interact with, and the services being the bit that provide the functionality and actually make the interaction work under the hood. So for an Alexa skill, we start putting our interface together by defining an interaction schema. You can think of this a bit like the HTML that gives semantic structure to the content that we see in a web browser. The schema uses JSON in this particular case, but it essentially provides the structure for our conversational interface. And the first thing we need with a conversational interface is an invocation name. That's the word or phrase that we use to invoke a particular skill. So let's imagine we're going to create an Alexa skill that will let us ask for information about conferences that are taking place in the not too distant future. So we'll choose conference info as the invocation name. From a usability point of view, it helps if invocation names are short, easy to remember, and quite clearly pronounceable so that the Alexa can recognize them quite easily. So hopefully we've managed to do that with conference info. There are other pieces of information that will go into our schema, including intents and types. Amazon provides a number of default intents that come with all Alexa skills. You have no choice. When you create a skill, these intents have to be present. So an intent is what happens when you intend for something to happen. The default intents are for simple things like asking for help or telling Alexa to stop or cancel. So these three are provided automatically, and that means that Alexa knows what words to listen out for in order to trigger them, and will automatically provide the expected functionality when you do. You can override and customize what happens when any of these three things happen, but there is default behavior provided whether you like them or not. Amazon also makes available a number of built-in intents. So this is a bit like a component library of intents that you can choose from. And they cover common ideas and possibilities. So for example, what happens when you say yes or no? What happens when you ask Alexa to repeat that or say something again? Or what happens when Alexa is not entirely sure what you said and needs to handle that part of the conversation gracefully using some fallback content. So again, you can use these and then you can customize them, but essentially they're ready and available out of the box if you want to make them part of your skill, which you almost always do. It's very hard to create a conversational interface without saying at least yes or no once or twice. So if we were to look at that default help schema, or the help intent as it was added to our schema, we can see that we've got the Amazon.help intent, and you can always tell the intents that have been provided by Amazon. They're prefixed by the word Amazon in capital letters. It makes them very easy to differentiate. And if you look at where it says samples as part of the schema, you'll notice that that's empty. That's because with the default and built-in intents, you don't need to specify the words that Alexa should listen out for. Amazon has done that hard work for you already. So in the case of the help intent, anytime you ask Alexa for help, it will trigger this intent. You don't need to tell it, listen for the word intent. But of course, the default and built-in intents are not the really interesting ones. It's the custom intents that you provide for your skill that make it unique in its own right. So returning to our conference info skill, we obviously want to provide an intent that will let someone come along and ask about a particular conference. So we will add an intent called about conference, and we will include one sample which says Alexa should listen out for the words about Australian Accessibility Conference. Now, if we were building this as a fully fledged app and I wasn't just showing you code fragments on screen, there would be an awful lot more samples in there. I would want to ask about SciTech Global. I'd want to ask about web stories, ask about Inclusive Design 24. And essentially what you would need to do is write a sample phrase for every variation that Alexa should listen out for. It's worth bearing in mind that that's an awful lot of different things. Even with just a simple skill asking for a pizza order, where there are just one or two types of base you can choose from and just a handful of toppings, you're actually talking about thousands of different conversational variations, because it turns out humans ask exactly the same question in lots and lots of different ways. You could say, give me information about a conference. You could say, tell me about a conference. Ask Alexa, I want to know about a conference. And then you'd have to type each of those variations for each of the different conferences that you wanted the skill to handle. I'm sure by now you are rapidly coming to the conclusion that that's a remarkably painful way to go about doing it, but fortunately you don't have to. Amazon makes it possible for you to define a slot. So if we take another look at our About Conference intent, but this time define a slot called Conference, we can change the sample so that instead of saying about and then giving it a specific name of a conference, we can just say about and then put the word conference in curly braces. And that word conference in curly braces effectively becomes a placeholder or a slot that we can use to fill with the name of any conferences that we choose. So we've simplified the way we define what Alexa listens out for dramatically by taking this approach of using a slot. And then what we do is we define all the different values we want to be recognizable in that slot. So we just give it lots of different types to name each of the different types of conference we want Alexa to be able to recognize. So instead of having, maybe 7 or 8 or 10 different ways of asking Alexa the same question about the same conference, we've simplified it. We only need to write the way of asking the question once, and then we just fill the slots with the different conference values. Having built our interface, we come now to the second part of it, and that's the speech services, what happens under the hood to make it all work. I tend to write most skills using Node.js and JavaScript. You can use Java and other languages too, but I find this one the easiest. And we begin by pulling in the software developer kit, the Alexa SDK. This is just a single line of code, but it's really what pulls in all the Alexa capability that goes into making everything work under the hood. And that includes different request types. So when someone asks Alexa to do something or for some information, it triggers a request. And that's either a launch request, the thing that happens when the skill opens for the first time, it's launched. The session ended request, what happens at the end of the conversation when you call it quits, you say you've had enough, you want to stop, cancel. And in the middle, what happens when you trigger one of the intents that we were talking about before, whether that's asking for help or asking for conference information. And it's these custom intents in the middle that are, of course, the really interesting bit about the skill. But let's take a quick look at the beginning of the conversation. Everything gets wrapped in JSON, and when you first invoke a skill, a bunch of information gets wrapped up in JSON and sent to the echo. It includes the timestamp that the conversation began, the locale in which it began, so we're assuming here it's going to be a device registered in Australia, and other information like the identity of the echo device in question. And this just triggers the launch request, which means in our code we need to write a launch request handler. Basically, this is where we define what happens when the skill is open. And some of this will look very familiar if you think back to the VXML examples. There is a prompt, the bit of information, the thing that Alexa will say to us first when we invoke the skill. There's also the notion of a reprompt. Alexa will listen for a response. If there isn't a response within about 7 or 8 seconds, she will speak the reprompt, a conversational nudge to remind the person on the other end of the conversation that they really need to say something, otherwise the conversation isn't going to progress terribly well. So here in the request handler, you define those two particular chunks of text, and then we wrap it up in the response handler and it gets sent back down the line to the echo device and the human listening. And this happens again in the form of JSON. So it sends back the messages that Alexa will speak, wraps them in SSML tags, more on that in a moment, and as I say, sends it back so that the human that invoked the skill gets a response. So for example, if I was to say, Alexa, open conference info.
Hello. Which conference do you want to know about?
Tell me about the Australian Accessibility Conference.
The Australian Accessibility Conference is the annual gathering of the members of OZeWAI, the Australian Web Adaptability Initiative. Hello everybody.
And there you go. Just the very simple beginnings of a conversation using an Alexa skill. Now, I mentioned SSML. This is where things get really interesting with Alexa skills. Speech synthesis markup language is another W3C standard. It's been around for quite a while, and this time, as the name suggests, it's a markup language that lets us control the way synthetic speech is presented. And this opens up huge amounts of possibilities because SSML is supported by Echoes as well as Google Home and other speech devices. So Alexa already has a voice of her own, and for those of you who have or have heard Echo devices, you'll probably be very familiar with them. What you might not be familiar with is that they each have different regional voices. Here's a few by way of example.
Hello, I'm Alexa, and this is how I sound in India.
This is how I sound in America.
And this is me in Canada.
Here I am in Australia. And this is me in the United Kingdom.
So lots of different regional variations for Alexa's default voice. But we can have a little bit more fun with the way she sounds. SSML has lots of different elements, one of the most basic of which is the paragraph or P element that lets us explain to Alexa that there's a chunk of text that should be regarded as a paragraph. For example,
the terror, which would not end for another 28 years, if it ever did end, began, so far as I know or can tell, with a boat made from a sheet of newspaper floating down a gutter swollen with rain.
So very clearly and beautifully read by Alexa. But if you're familiar with that bit of text, you might think, not entirely the right voice for the job. If you're not familiar with it, it's the opening line or two from Stephen King's It, one of my favorite books and possibly the most terrifying book ever written. The character that's narrating those opening lines is, in fact, an American man of perhaps late middle age. So, as lovely as Alexa sounds, it's not entirely the right choice of voice for the content in question. Fortunately, SSML lets us do something about that. The first thing it lets us do is choose a more appropriate voice. If we choose the available voice Matthew, it gives us the right gender. It also gives us the right accent. Matthew is one of the US voices available on the Echo. We can also do something about the emphasis for different parts of that sentence. Instead of reading it in a very light and conversational tone that is Alexa's default, we can use the emphasis element to put stress emphasis on different words within the sentence. We can deepen the emphasis, put more emphasis on certain words, or we can lighten the emphasis and just lift it up a little bit. And if we do that combined with the choice of voice, the output sounds quite remarkably different.
The terror, which would not end for another 28 years, if it ever did end, began, so far as I know or can tell, with a boat made from a sheet of newspaper floating down a gutter swollen with rain.
And suddenly, with just one or two SSML elements, we've changed the entire experience of listening to that passage of text in a way that seems, to me at least, much more appropriate to the content. But listen again to that voice element, and in particular, pay attention to the way the word years is announced.
The terror, which would not end for another 28 years.
Comes out as years. This actually sounds quite appropriate. Stephen King bases most of his books, It included, in New England, and that way of pronouncing the word years is a sort of New England kind of a way of doing it. The reason for it actually, though, is nothing so deliberate. It actually comes about because Matthew is a US American voice, but I recorded that sample on my Echo, which is registered in the United Kingdom region. So what has happened is it has applied British pronunciation with an American accent. And what has actually come out, quite happily, as it turned out, is a sort of cross English American accent, which is almost exactly the description of a New England accent. But we can do something about that too if we wished. We can use the lang attribute. So not only can we say use Matthew, which is a US English voice, we can use the lang en US attribute to say make the pronunciation as well as the accent American. And if you listen now, particularly again to that last word, you'll hear it sounds somewhat different.
The terror, which would not end for another 28 years.
Definitely more American sounding that time. Let's take another example. We'll go back to our P element and ask Alexa to speak this famous quote.
Hello, my name is Inigo Montoya. You killed my father. Prepare to die.
Now that's just not right in all sorts of ways. Far too cheerful, far too British, and entirely the wrong gender, accent, and probably many other things besides. So we can again use the voice element, this time with the voice Enrique, which admittedly is a Spanish voice, not a Southern American voice, but I think it's forgivable. We'll also use the break element, and this just lets us put in some more appropriate pauses. And ultimately, if we bring these two things together, we sound a little bit more like the thing we'd expect.
Hello. My name is Inigo Montoya. You killed my father. Prepare to die.
It's not perfect, but it's an awful lot closer than it was. There's another element we can use, sentence or S. This just lets us choose smaller chunks of content within the bits and pieces to be spoken by Alexa. And this time, a few sentences from Winnie the Pooh.
Piglet sidled up to Pooh from behind. Pooh, he whispered. Yes, Piglet. Nothing, said Piglet, taking Pooh's paw. I just wanted to be sure of you.
Now, actually, that wasn't too bad at all. Got the right accent at least, and the nice, light, kind of familiar conversational style is pretty appropriate to the content. But we can still play around with it a bit more, this time with the prosody element. Prosody is the term in speech pathology and linguistics given to different characteristics of voice, amongst them volume, pitch, and rate. So here we can, again, choose a different voice with the voice element. This time we'll choose Brian, which is a British male voice. Again, the Winnie the Pooh books are narrated in recollection by Christopher Robin, who owned the bear Winnie the Pooh. But in this case, the person who is telling the story is also bringing to life characters from their own imagination in the form of Winnie the Pooh and Piglet. So we can use the prosody element to give Piglet in particular a slightly different flavor to his voice. We can make it a little higher pitched. In places, we can make it a little bit whispered. We can make him sound just a little bit more squeaky and a little bit more Piglet-like, and that sounds like this.
Piglet sidled up to Pooh from behind. Pooh, he whispered. Yes, Piglet. Nothing, said Piglet, taking Pooh's paw. I just wanted to be sure of you.
So SSML gives us enormous capability to create conversational experiences that are remarkably different from the ones that we are accustomed to, even with Alexa skills as popular as they are. Amazon actually lets us take this a bit further. They've come up with a number of proprietary SSML elements. Now, it would be nice if these became part of the official SSML standard, but they are at least available here. So, for example, you can make Alexa whisper to you.
Shh, be very, very quiet.
Now, I think they invented this in hopes of inviting confidences with your Alexa skill. Between you, me, and the gatepost, it scares the hell out of me. If my Alexa ever came out with that, particularly if I was alone in the house, I would be out of the door in no uncertain terms. But it does have uses. If you have an Echo, you can actually whisper your question to Alexa and she will whisper back, which is actually quite handy if you don't want to disturb people who might be nearby. We can also do things around emotion, thanks to some of the proprietary elements that Amazon makes available. Let's take this lyric from a reasonably well-known song.
I'm so excited, and I just can't hide it.
Sort of cheerful, but not really what you'd call excited. But thankfully, the emotion attribute with a name value of excited changes the dynamic quite a lot.
I'm so excited, and I just can't hide it.
Definitely sounded excited to me. But being kind of converse sort of a person that I am, I quite like this one too. You can make us just sound a little bit more dejected. In fact, if you were voicing Eeyore, going back to the Winnie the Pooh example, this would be a perfect way to think about doing it.
I'm so excited, and I just can't hide it.
You can just hear the dejection in that voice. But that's exactly the same Alexa voice, just having the emotion tweaked a little bit to give the cadence, kind of the delivery, a very different turn. You can also get Alexa to sound like she is reading the news.
Now it's me, with the news. Today absolutely nothing happened. Everybody went and had a nice cup of tea instead.
And these are really quite handy ways to add just a bit of character to your skills. It would actually be quite hard to produce that newscaster kind of a voice for yourself. It would be possible, but you'd have to put a lot of thought into it. So the fact that you've got these ready-made available kind of voices, if you like, or tones of voice is a useful effect. You can also have some fun with it. Alexa doesn't like cursing or swearing very much. In fact, if you write any swear words into your Alexa skills, she will bleep them out. But this too is something you can have a little bit of fun with, because sometimes it's amusing to bleep things out when there's nothing to bleep in the first place.
Frankly, my dear, I don't give a...
So sometimes you can use these things in unintended ways to good effect. The last thing I'm going to share with you is the idea of an interjection, something else that Amazon has come up with. They have created a number of just short interjections, and there are sets of these available for many different regions of the world. And they just add a little bit of humor and character to your skill. So here's a selection of those for the United Kingdom.
Ace. As if. Bar humbug. Blimey. Cha-ching. Crikey. Eek. Good grief. Hiss. Moo. Nom nom. Oof. Oi. Simples. Tick tick tick. Uh-huh. Wee.
And of course, I couldn't possibly come to an Australian conference without giving you a little bit of the Aussie way of doing things too.
As if. Aussie, Aussie, Aussie. Oh man. Blimey. Bummer. Checkmate. Fair dinkum. Fair go. G'day. Good on ya. No worries. Struth. You beauty.
So although there is perhaps something to be said for some terrible national stereotyping going on there across all the nations that they do this for, they are kind of good-humoured and affectionately amusing ways that you can add some character and feeling to your Alexa skill. But what happens if we think about conversational interfaces in the browser? Because let's face it, browsers are still very much things that we are familiar with, we use probably most, if not every day. Good news is we can create conversational interfaces in the browser as well. One of the ways we can do this is to use the Web Speech API. This is an idea that has come out of a community group at the W3C. It hasn't made it to an official standard, though I remain optimistic that it may. It's actually very well supported in browsers already, so getting it to become a W3C standard to some extent is a formality that doesn't get in the way of this being a very usable technology. There are two interfaces to the Web Speech API, speech recognition, the ability for the application to listen to what someone is saying, and the speech synthesis interface, the bit that enables it to reverse that process and say something back. And again, this goes right back to that idea of automatic speech recognition, converting something to text. The web application can then do something with that, and then if it wishes, convert that text back to synthetic speech and have it spoken. So it starts off, if we look at the speech synthesis side of things, because after all, this is a talk about the conversational part and the speech output, we start by creating an utterance object. This is just the object that manages the speech synthetics, the characteristics, the voice that's chosen, what it says, and all those kind of bits and pieces. We tell the utterance what we want it to say just by using the text attribute. We give it a text string. Again, that idea of text being the fundamental component, building block of a conversation. So whatever it is we want the thing to say, in this case I've chosen tequila, but then I would. That's what I would get my application to say. We then just use the speak method, and we simply just apply this, and it basically says to the utterance object, whatever it was you were fed through the text attribute, speak that now. And by default, the web application will use the default text-to-speech engine on your operating system for the browser. Every operating system has a collection of text-to-speech engines made available, built in by default, and different browsers will also feed into that as well. So for example, if you look at the text-to-speech engines available on Chrome on Windows, you'll find you've got many more available in that browser than you do perhaps in Safari on macOS. You can get a collection of those voices, so the get voices method will let you query the available text-to-speech engines that are available, and from there, of course, you can start to make choices about the one you want your web application to use. For example, you can use the voice method to apply. In this case, I've chosen the Microsoft Hazel voice, which is the default Microsoft British female voice. But as I said, you've got lots of choices. So again, you can choose the voice characteristic for your web application. And why is this a useful thing? Well, I think one of the applications of the web speech interface could be enabling everybody who wanted to listen to web content rather than watch it or look at it. For example, like this.
News headline, nothing happened, reported on the 1st of April. Nothing happened today. Everybody went and had a cup of tea instead.
Since I first wrote that proof of concept, I actually think now the Edge browser does let you do exactly this. You can ask it to read you content that's displayed in your browser. As a screen reader user with a wireless headset, I routinely start an article reading with my screen reader, and then I wander off around the house. And it's a very useful thing to be able to multitask that way. I can make a cup of tea while I'm listening to a news report, for example. And I think, and have done for quite some time, that if everybody had that ability, it would be quite a useful thing. And reading the news is perhaps a good example. So that's one way we could create a speech application in the browser that was really kind of quite useful. There's something else as well when it comes to browser-based applications, and that's the CSS speech module. Sadly, this is not fit for use in production code because it really doesn't have any good browser support worth mentioning. I recently became co-editor of this spec, and I really hope we might be able to encourage more browsers to implement support for CSS speech because I think it has huge potential. It's actually been around in various forms for about 20 years. It began life officially as oral style sheets in the early 2000s. And it is essentially a collection of CSS properties that let us define the characteristics of a synthetic speech experience as opposed to the more conventional use of CSS in terms of the graphical or visual presentation of content. It has some similar ideas. It has a box model, an oral box model, but it also has many characteristics that we've started to become familiar with through this this talk already. So there are lots of characteristics that we could use to describe the properties of synthetic speech when it's used in the browser. This could be using the Web Speech API, or if I get really lucky, we'll convince screen readers to support this off the back of browsers supporting it more. So it starts off with the speak property. This essentially, when it was applied to an element, would say the contents of this particular element should be spoken or should not be spoken. This is quite smart in that when it's supported, it'll actually be associated with the value of the display property. So if display is set to none, so you can't see something visually, and the speak property is set to auto, it will automatically reflect the display property. So if something can't be seen because it's display none, it will automatically be assumed it shouldn't be spoken either. But this essentially lets you determine whether a piece of content should or shouldn't be spoken. We can then use the voice volume property to change the volume. And one of the concerns that is often raised about CSS speech is that it could be used to create really bad experiences that would actually be a pretty big problem, particularly for people like myself who depend on screen readers and synthetic speech. But the technology is a bit smarter than that. It's the same with SSML, it's the same with web speech, it's the same with CSS speech. There can't really be any extremes, because when you say using CSS speech, you want the voice to be extra loud. It's just extra loud relative to the volume that someone has their system set to already. And they're not, great leaps in volume. You can't suddenly, quadruple the volume level and scare the heavens out of someone. It doesn't work like that. The increments are much more subtle than that. And it's the same with things like voice rate. You can speed up or slow down the rate of speech, to a reasonable degree, but you can't suddenly send it completely off the chart. Voice pitch, like the prosody element, as with the pitch before it, lets you just change the pitch to high or lower than the average that the text-to-speech engine operates at. And why do I think this has huge potential? Well, I've mentioned a time or two that I listen to a screen reader. For those of you that have heard screen readers, or indeed may use them like me on a daily basis, you'll be aware that they say everything in exactly the same voice. It doesn't matter if they are announcing the winner of an election, that a kitten just got rescued from up a tree, that there's been some terrible tornado or typhoon or tsunami that's done terrible things somewhere in the world. It all comes out in the same flat, boring voice. And it gets really, really boring, like this.
News headline: Nothing happened, reported on April 1st. Nothing happened today. Everybody went and had a nice cup of tea instead.
Now, don't get me wrong, I am all in favor of a nice cup of tea, but really, nothing happened. That whole kind of tone of voice just sums it up completely. It's the audible equivalent of seeing everything, every single web page in black, white, grey, monochrome. That's what the early web looked like. Right back at the very beginning, most web pages had kind of grey backgrounds, black text, and gradually we got used to browser styles and a bit more interesting colours. But for a screen reader, that's what the web is still like. Everything sounds the same. But if we could get browsers and then screen readers to support CSS speech, we could just perk up the experience no end. Kind of the equivalent of putting in some nice colored accents, some nice shading, a bit of, changing across the color range to add that kind of visual interest. Nothing extreme, nothing major, in the way that we don't get really extreme visual design because people can't read or see it properly. We wouldn't get that problem with audible design either, but with some very subtle changes, the experience of that same news article can sound a little bit more engaging.
Heading level 2. News headline: Nothing happened, reported on April 1st. Nothing happened today. Everybody went and had a nice cup of tea instead.
So as I said, nothing major, nothing extreme, but just a little bit faster speech to catch attention, a little bit slower when it's perhaps something less important, and then a nice steady cadent voice for the main part of the news story. And those things collectively just make the listening experience a bit more interesting, a bit more engaging, and that after all, is really what we're after when we talk about any form of interface design. It's why we do visual design. We want to make something appealing to look at. We want to draw people's attention to certain parts of the content. Why not think about doing the same with conversational interfaces? Make them more more audibly engaging, be able to draw our attention to certain parts of the conversation, or just, invoke some reactions or responses in an auditory sense. So I hope this has given you some things to think about in terms of where and how we've been thinking about conversational interfaces over the years, how we put together skills on one of the most popular speech platforms available in our homes at the moment, how we can translate that into the browser, and where that future for browser speech might take us with a little bit of luck and good fortune, so that we can start to really create amazing, engaging, enriching experiences that are conversation based as much as visually based. And once again, thank you so much for inviting me to be part of the conference. I look forward to hearing more of the talks as it progresses, and thank you once again.